Hello, everyone. Happy Monday. I hope you're doing well. This is Fozzie. For those that haven't exactly seen Fozzie, you want to say hi? You want to say hi? Wave? I don't think he's going to wave right now. I'll wave for him. Hi. I hope your day is going well. This week we're going to continue. Hey, everyone. He accidentally paused the recording. Um, he knows the space bar does something, but he didn't know it would pause the recording. Stop it. I'm going to put him down. You can be over here. But anyway, it's currently Monday, and I am actually leaving for the hospital for a little bit, and I'm going to be at the hospital until Wednesday afternoon. So I'm going to go ahead and try to film today's and tomorrow's content, so to speak. I didn't have enough time to make everything for tomorrow, so you're going to have to try some on your own. You can still message me. I'll be available, but I won't really easily be able to film, if you catch my drift. Maybe I'll put a PowerPoint up for some of the assignments tomorrow and show the steps. But I just wanted to go over as much as I could. And then Wednesday is going to be a quizzes. So you can do, I don't know if you can see them from there. So we can do a quizzes on Wednesday that I'll post on Canvas. But this is just kind of a continuation of logarithm. So I'm going to do a quick review, and then I can put a kind of a time thing up for when we start tomorrow's content if you'd like, or maybe you can see in the video or pause, or you can just continue and do as much as you want on Monday, and that way hopefully Tuesday is a little more lighthearted. Anyway, I hope you're having a good day, and let's dive in. Hey, I moved the camera so you can see him a bit better. This is my office, by the way. Although it's more my wife's office. But anyway, this should be a review. We talked about how when you add two logs with the same base, you can multiply them, or vice versa. And then same with subtracting and dividing. And then the power properties of logs. That's going to come back into play. But basically, if you have an exponent in the log, you can move it to the front of the log. Now, this should also be a review, but we didn't spend too much time on this. There was a bonus question on the quiz that had to do with the change of base formula. But this is going to come back into play big time because we're actually going to be using our calculator a bit. And basically, you can't always plug in whatever base you want, but a natural log, or a regular, I shouldn't say natural log, that's something different, but a log with a base of 10, if you needed to figure out what this was, you could do log base of 10x divided by log base of 10b. I'm going to give you a couple more examples, but basically if you had this equation and you need to solve it on a calculator, you would have to do this, and you get 1.5. Now, let's look at a calculator. On a calculator, to do a log, it's going to be this button right here, but you'll notice when you plug it in, it doesn't give you the option to change the base, so it's always going to be a log of 10. But you're going to use this button, and you can still solve any log based on what we just went over. Now, while you're in the classroom, you can use this, but I know that you might not have this option at home. I did recommend at the start of the school year you get it because you can use it on the SATs, you can use it on the ACTs and things like that. But if you need a temporary version, there is a TI-84 app which uses the same idea. And I downloaded a ROM, or basically a simulator that you need a ROM to play. I downloaded this WAB ITEMU, or Wabbit, I guess, because it's a Wabbit. And the ROM that comes with it doesn't work. I had to download a separate ROM, but essentially this could be a virtual TI-84 calculator for your computer if you'd like. There's a couple options if you'd like, or again, you can use the ones in the room. Your phone can do logs, but it's a little funky when it does logs on the phone, because I think it only does like one at a time. I'll have to look at it. All right, so again, if you needed to solve for these on the calculator, you would have to plug them in from what you'd have to plug in the log divided by the base of the log, both set to a log base 10. I was originally going to have you try this, but I think you get the idea, and I'd rather spend more time on the actual equations. So it's time for our fancy dancy foldable. You can go on the next page if you want, and you can start this at the top because there's a second part to it with even more examples, or you can start a page and then do the next examples on the back. He loves listening. So we're going to spend a bit of time on solving a little bit of harder equations, and some of these we're going to need a calculator, some of these we have to think a little bit outside the box. And exponential equations have one or more expressions that have a variable as an exponent. We already kind of know that, but we haven't had to solve equations. We've mostly seen graphs, or it's been set equal to something. But in this case, we have to solve. So you can see in example 1, we have 8 to the power of x equals 2 to the power of x plus 6. Now, to be able to solve this, we have to think a little bit outside of the box. You have to consider that 8 is the same as 2 to the power of 3, right? Like, 8 is the same as 2 to the power of 3. And this works really well because now we can solve for our exponents. Because 2 to the power of 3x is now equal to 2 to the power of x plus 6. Now you can think about this in two different ways, and I added an extra step when we do some of the practice problems I gave you. You can think about this as logging base of 2 of each side, here and here, or you can just think about, okay, we're trying to solve for x. Well, if this is 2 for both, then the only thing that changes from the left side to the right side of the equation is my exponents. And so to solve for x, the only thing I really am worrying about is 3x and x plus 6. I'll try to lay it out even better when we do the actual assignment. Just for sake of room, I didn't put log of 2 on both sides. But if you log 2 of both sides, all you're left with is 3x equals x plus 6. And then you solve. So you subtract x, and you get 2x equals 6. So x equals 3. So you're going to have a couple like that on the practice problems. They become easier the more you do it. You usually just have to think of how to make this and this the same. And I'll show you a few examples of that in a little bit. Now on this side, we have 5 and then 200. They don't really work well together. There's no 5 to the power of any number that would give you 200, and we can't break 5 down any more than it already is. So we're going to have to log both sides. So we have log 5 to the power of x minus 2 equals log 200. And this is, and now we want to get rid of our log, or sorry. Now, using that idea we had, we can actually bring this to the front. So we can bring x minus 2 out here. And then now we have x minus 2 times log of 5 equals log 200. And we can actually just divide log of 5 on both sides. It'll cancel out on the left. And then x minus 2 equals log 200 divided by log 5. And if you do that on your calculator, it's 3.292. And then our last step is we just add 2 to the other side. So that was the condensed version of what we're going to spend a bit of time doing. Hopefully this is just building on top of what you already knew from last week. So I'm actually going to start diving into the assignment for today. I have stuff to do the whole assignment with you, but if you want to pause around now and try the rest on your own and then come back to this video, you can, especially because you're going to have all of class today and you're going to have a lot of class tomorrow to only do a few questions. Or if you want, you can watch me do a few of them, try some on your own, and come back. It's really up to you on how you want to tackle the rest of this assignment. But yeah, I wanted to give you the option, so feel free to pause now. All right. You probably didn't fully pause, but if you did, I hope that all these answers will look familiar to you. So you can solve a blank by taking the logarithm of both sides. You can solve an exponential equation by taking the log of both sides. Exponential equation. Okay, so we have 4 to the power of 2x equals 32 to the power of 1/2. Now this one might be the hardest one out of the first couple. It is just like our first example. We want to try to find out how to make, oops, I spoiled it. We want to find out how to make this and this the same. And 32 is 2 to the power of 5. You probably tried 4 at first. Hopefully you didn't give up after that, because it's actually 2. We can do 2 to the power of 5. And then 4 also can be 2 to the power of 2. So we can just change the left and the right to be 2's, but the left is 2 to the power of 2 times the exponent that was already there, and then 2 to the power of 5 times the exponent that was already there. So again, you're just trying to see, how can I make these things the exact same? And in this case, it's 2 to the power of 5 and 2 to the power of 2. And so you put those here in place of the 32 and the 4. And now you can either think of, okay, they're both 2, so the only thing that's changing is the exponent. Or like I said, you can think about, you take the log with the same base on both sides to help bring those exponents down. And basically they cancel out. I don't love saying they cancel out, really. They just bring the exponents down. Or you can think about the property where they bring it to the front. And all we're left with is 2 times 2x equals 5 times 1/2. And then you can go ahead and distribute. If you distributed earlier, that's completely fine too. And now we just need to divide 4 on both sides. Remember, when you're dividing by a fraction on the other side where you already have a fraction, you're basically just multiplying your base. Or you can think about it as you're dividing 5 like 4 times more than you already were. So our final answer is 5/8. 5/8. Hopefully that one really wasn't too bad. I think the hardest part is just trying to figure out what base to make them both. And once you get that, it's super easy. In fact, the next one is going to be even easier. So again, we want to figure out how do we make this the same base. Now, if you're still like, this one might be a good one to try on your own if you want to pause really quick, because it's quite obvious that you're going to try to make them both 3. 9 can become 3 squared. 3 squared. So instead of 9 to the power of x, we can change that to 9 to the power of 2x. 9 to the power of 2x. And now they're both 3's. So you can either think that we're just going to focus on the exponents since they have the same exponent, like same number that they're exponentialing. That's not the way you should phrase that. Or you can think about when you log both sides, all you're left with is your exponents. And then we solve. So 2x equals x minus 2. We're going to subtract x on both sides. And all we're left with is x equals negative 2. That one was super simple compared to the last one. Yeah, hopefully it's clicking even more. And we can try the next one. So again, just when you're looking at this, you can notice that how can I make these the same on the same numbers that are being that have exponents, and obviously it's going to be 2 because 4 is the same as 2 squared, right? So essentially we can make it 2 to the power of x, 2 to the power of 2 times x plus 1. Now we just want to take the log of both sides, and then all we're left with is our exponents. So x equals 2x plus 1. We can distribute the 2 if you'd like, or you could divide 2, but I think it's easier to distribute the 2. And then we can subtract 2x, and all we're left with negative x equals 2, and then we get negative 2 again. That just is happenstance, so it's the same answer, but x equals negative 2. And if you test that, you could see that if you plugged in negative 2, that would be 1/4. If I plug in negative 2, that would be 4 to the negative first, which is 1/4. Woo! All right, next one is a little different, but hopefully still an easy concept. So this one is like the second one we did, if you want to try this on your own. Or if you'd like to see an example, I can do this one, and then the last one is like this too. So we have 4 to the power of x equals 10. We can't make these the same base. So we're just going to log both. Now, you probably can tell what log of 10 to 10 is going to be 1. But in case you didn't, that's fine, because we can plug that into the calculator in a second. But we want to move our x. We're going to use that power property of log so we talked about, where we can bring the x to the front. So again, this looks just like the second example we did in our notes. And now to get rid of our log 4, we can just divide log 4 on both sides. Cancels out on the left. You can plug this into the calculator, or you can do 1 divided by log 4, because we know log 10 of 10 is 1. Either way, you should get that x is about 1.661. Again, feel free to try that on the calculator to practice, but you should get x equals 1.661, whether you did it as 1 divided by log 4 or whether you did it as log 10 divided by log 4. All right, let's try the next one. Okay, so this one is actually like the first three we did. Or at least that's the way I went about solving it, because I at least can quickly see that we can make 1/4 have the same be 1/2, because 1/4 is actually 1/2 squared. So if 1/4 is 1/2 squared, then we can change the 1/4 to 1/2 squared times the existing exponent, which is 2x. So now to solve both, just like we did with the other ones, we're just going to log both by a half, or you can just consider that now all we have to care about is our exponents. I went ahead and I guess I did 2 times 2x here, and that's how I got 4x. So now we have 4x equals x. You might can tell already what it's going to be, but just in case, we're going to subtract x on both sides. We get 3x equals 0. The only thing times 3 that could give you 0 is 0. So this answer is nice and simple, and we probably could have even figured it out potentially earlier on. I could see it here because there's no number that could make this true except for 0. Probably even earlier on we could think that, I guess, 1/2 to a higher power than we have over here. And we know it's a higher power because they both have just one x, but this is multiplied by a bigger number. So regardless what you put in here, this side would be would have a bigger exponent, a bigger denominator, so it's technically a smaller number than the right side. The only thing is 0. Fun, fascinating. All right, let's move to this one. So this one, you'll notice it's a decimal, but that's okay because we can use that equation. It's going to be just like, not the last one we did, but the one before, or the second example that we did. So if you want to try it on your own really quick, feel free, or I can kind of go over it with you. Sorry, I don't know what's going on there. So to solve this, we're going to log both sides. And then we can use our power property of logs to get rid of our exponent, or not get rid of it, but to move it to the front so that it's out of the way of this 2.4. And now to get rid of the log 2.4, we can divide log 2.4 on both sides. They cancel out on the left side. And then you can plug log 9 divided by log 2.4 on your calculator. You can't do this in your head. I couldn't do this in my head. I'm sure if I had a bunch of paper, but just plug that in on your calculator and you get about 2.509, but I rounded up to 1. And then now we just the rest is algebra. We're going to move our 1 by subtracting 1 on both sides, and we get 3x equals 1.51, and then we divide by 3. Again, feel free to do that on a calculator, and you get that x is about 0.503. And that concludes today's portion of the work. Luckily, that only took about 25 minutes. So I'm going to go ahead and start diving into tomorrow's. You can take a break if you'd like and come back to it. You can go ahead and get a head start. Whatever you feel comfortable or confident with, but I'm going to go ahead and dive in. All right, so grab your foldable again, and like I said, below what you just wrote or on the very back of what you just wrote, we have a few more examples. It's kind of built a little built on top of what we've already done. So let's go ahead and dive into some more notes. So log 3 and then x in parentheses x plus 5 equals 2. The best way to solve this is to basically go backwards for a second, because there's not much we can do right here, but we can bring our 3 back to the other side, because remember, this is the opposite, or like to get here, we would have had to log both sides. Basically, we can do this based on what we've already gone over. You can go back to your notes for the equation of how logs work, but basically we're trying to figure out 3 to the power of x plus 5 equals 2, or sorry, 3 to what power of x plus 5 gives you x plus 5 equals 2, or x plus 5 equals 3 to the power of 2, because anyway, you can think, if you wanted to go backwards, if I log 3 both sides, I can go backwards here. We went that direction, because now we can solve. So 3 squared is 9, and then 5 plus 9 is 14. So that's it. You're going to have a couple that are like that. You just have to go backwards a little bit and then solve for what's left. Now the next one, we're subtracting them. If you remember, when we subtracted, we can actually divide, subtracted with the same base, we can divide. So we can actually do 45x divided by 3. 45 divided by 3 gives us 15. And then we want to get rid of our log. Well, we can use the same idea that we did for the first example here, and we can move our log to the other side. Remember, if it doesn't say anything, we assume that it's base 10. So we can move 10, and 10 to the power of 1 is 10. And then 10, and then we're going to divide 15. So we get 10 over 15, which is the same as 2 over 3. So hopefully these are clicking. They're stuff you already mostly know. It's just using them more and more to solve things algebraically. All right. So for C, there's a couple different things, but the main thing I see is we can move this 2 to the front. And now I'm left with 2 times log 4 x equals 7. And I can't really do too much at the moment, but I can divide 2 to bring it to this side, because I'm slowly trying to get x by itself. And I get 7 over 2, and now we can do what we did earlier, where we move the 4 back to this side, and we get x equals 4 to the power of 7 over 2. Now that's 4 to the power of 7, and then you take the square root, or actually you can take the square root of 4 first. That's what 1 over 2 is. And so you get 2 to the power of 7. So there's a couple ways you can go about this, or you can plug it into a calculator. Either way, you're going to get 128. All right. I'm hoping it's clicking. Feel free to message me. Feel free to talk with each other. Maybe I'll post another video if that helps. But we're just using all of our tools to slowly solve this algebraically. All right, let's try the last example. So here we are adding 2 with the same base, which again is actually multiplication. So we're going to do x times x plus 9, which is x squared plus 9x. And this should be in parentheses, my bad. And so now we want to bring this log to the other side again, the same way we did the last couple. And so it's going to be 10 to the power of 1. Now, we want to solve for x. And I'm smiling because I knew this one was coming. This is going to be x squared plus 9x minus 10 equals 0. I moved the 10 to the other side because in order to solve this, we have to do a couple different things. But you'll notice it is a quadratic equation. Luckily for us, this one is easily factorable. If you want to do the x method, think about it as what times negative 10 would add to be, or what would multiply to be negative 10 and add to be 9. And it would be 10 and negative 1. So we get that it's x plus 10 and x minus 1. So to make these equal to 0, it would be negative 10 and positive 1. This is a little trickier, and I just try your best on them or solve it as much as you can. I shouldn't be smiling as much as I am, but I think some of those are fun because they use knowledge that we've already talked about. Right, Fozzie? I feel like I haven't checked in on you. It's just funny you're just lying there. All right, let's look into the next one. Or, sorry, I said the next one, but we're actually going to start going over the assignment together. So if you are picking up on the next day, go ahead and take that out. Or if you haven't got it from the sub yet, you should get it from the sub. And we're going to kind of slowly work through. I only had time to do 2 examples. I'll try to update with more, but again, I need to get ready really soon to head out. All right, so this one's super simple because think about it. If you moved them to both sides, regardless what you do, like I said from yesterday's, it's going to be the same bases and things like that. All we have to do is worry about our exponents. This one is a lot simpler than you'd expect in that reason. And then it's just basic algebra. I started with moving the x to the left. You can do it a couple different ways. And so I got 8x plus 1 equals 2. And then I just subtracted 1. And I got 8x equals 1. And then I divided by 8. And we get x equals 1 over 8. So hopefully this one, super easy, and it helped you go ahead and get that out of the way so you can work on the slightly harder ones that involve factoring. All right, this one it's similar to, I believe, the second example, or maybe it was the first example from today. We're going to move the 6 back to the other side from where it kind of came from. So remember, if you have a log over here, that means that it was, or it can be, 6 to the power of 3. Now we just slowly solve. First, 6 to the power of 3 is 216. And then we're going to subtract 3, and we get 213. Unfortunately, it's not a perfect even number. So when we divide by 213, you can either leave it as a fraction or as 106.5. Yeah. All right, everyone. I will try to make a PowerPoint or something to explain the next steps on how to do the rest. For now, just try them on your own. If you don't hear back from me for a little bit, it's gonna take it might take till Wednesday afternoon or Thursday morning till I can get to how you solved them. So just try them, and then you can review the answers, or I'll make a video going over the answers. Hopefully this is clicking really well, and then I have some more that I'll do for Thursday and Friday, and I'll keep you guys updated. But yeah, thank you. Please be good with the sub. If you don't mind, please do the sub a favor and clean up. I imagine with me not being there that the room might be a little messier than normal. So if you don't mind helping the sub clean up a little bit, just be respectful, and I don't know. I wish you guys the best. If you like these videos too, this was kind of my idea of maybe I can give notes these ways, and then we can have more time to practice in the class with a slight element of a little bit more socializing rather than trying to cram it all into class. So if you like this too, let me know. And I just haven't had time, but this is something I think I'd prefer, because then I don't have to get on your case for talking or anything like that, as long as you're watching the videos and getting your work done. Anyway, Foz, do you want to come say bye? Do you want to say bye? No? Yeah? No? Do you want to say bye? Say bye? Yeah. All right. Fozzie says bye. Have a great day. Keep me updated. Bye.